Hi, I'm Harshil Sumaria, a Power Systems and Data Analytics Engineer at UK Power Networks. We're really excited to be launching our DSO Dashboard beta, which is delivering unprecedented live insights into our electricity network. We've put together this video to take you through the dashboard and some of its main features. We've launched in beta mode for now, and we want to build upon the dashboard based on your feedback. So please do complete the feedback form or get in touch with us at opendata@ukpowernetworks.co.uk. Have fun! The aim of the DSO dashboard is to open up information on what's happening on our network in real time. So the data you see here is refreshing every 10 minutes, giving an up-to-date view of the power flows, the voltage, the frequency, and what all the generators connected to our distribution network are doing at a specific time, as well as looking back over the past year or so. We believe it's really important to share the data that we have on our network with everyone as we pursue net zero and the electrification of new industries such as heat and transport. This will become more and more important. We are releasing the dashboard in a beta trial mode. The aim of that is to co-develop the dashboard with the users. So anyone who is watching this video, anyone who comes to the website, we want to hear your feedback and develop the dashboard with you to make something that is fit for purpose but also accessible to everyone. What you can see here is we're currently looking at Canterbury North. This is one of our grid supply points. A grid supply point is where the electricity network moves from the transmission network to the distribution network. It's how we get power into our network from National Grid. And in the first release of this dashboard, we've opened up 10 of these grid supply points and the data that goes with them. In future, we'll be adding more and more grid supply points, as well as going down to more granular levels, getting right down to the substations which directly serve you. So if you look at the top left here, we've got a filter for different grid supply points. If you choose any of these, you'll be taken to a different set of data showing what's happening at that specific region. In the top right, we've got a filter for time. Currently we're looking at the last 3 days, but we could quite easily look at anything up to the last year. We could define our own time range as well, looking at a specific time. For example, if you want to know what was happening on the network on the 25th of December, you could just type that in and it would go straight to it. Now, scrolling down a bit, at the top here we've got key performance indicators. These show what is happening on the network currently. So currently you can see at Canterbury, we've got a frequency of 50.19, the voltage at the bus bar is 130, the active power going through the transformers is just shy of 40 megawatts, the reactive power through those transformers is -7, so that means we're giving back to National Grid rather than taking reactive power from them, and all the generators connected in that region are summing up to be producing 145 megawatts right now. Now scrolling down a bit further, you can see 4 graphs which demonstrate what's happening in terms of the demand on our network. So the active power flow, when this goes negative, this shows that this region is actually providing power to the transmission network rather than taking from it. This is one of the things that we've really started to see develop on our network in the last few years, especially with the advent of more distribution connected energy resources. You can see the same for reactive power. That again is showing what's being either taken from National Grid or being given to them. And voltage, this shows how the voltage at that grid supply point is changing over time. And frequency. For frequency, we decided it would be best to show the average frequency as well as the minimum and the maximum to show there can be slight variations in frequency from different geographical regions, and that's impacted by a whole host of factors, including what the generators connected there are doing, what the loads connected there are doing, and what's happening on the rest of the network. Frequency is very dynamic, and so to capture that we wanted to give a bounding to it as well as showing you the average. These 3 graphs, active power, reactive power and voltage, are specific to the grid supply point you're looking at, whereas frequency is aggregated to a slightly higher level to allow us to average out across more measurements. Now going down to the bottom, if we just close this tab for demand, you can now see the tab for supply. This is what all the generators connected to the distribution network are doing and how their trend over time is changing. Now, looking at the first one, this is just a time series graph showing what all the generators are doing over the last 3 days, and you can see this area of Canterbury is greatly dominated by wind. Now if we look in the bottom left, we've got a graph showing at the most recent time point what the mix of generation was. So this graph here relates to this last time point at the end of this time series graph, and it's quite cool to see. Just if you combine the green and the orange, that's the majority of this donut chart. With this bottom chart here in the corner, we wanted to provide a bit of context at the total amount of generation connected to this area. Not all of the generation connected has live metering, so you'll see that there is a lot more solar here, 81 megawatts connected, than what is actually metered, because the peak for our solar so far in this chart is 24 megawatts, whereas there is actually 80 megawatts of solar connected in this region. Over time, we will be able to increase the amount of metering on the network and get all of this unmetered generation into this chart as well. But for now, just to provide context, that a bit of scaling may be required on some of these numbers to get a true picture of what is connected at this region. Now, if we pick a single graph and zoom in on it, we can click on this tab here and click on the view button. This gives us a whole screen view of this graph, which is quite important when you're looking at so many different trends to get a proper view of what's happening. You may decide, in fact, that you'd rather just look at the raw data rather than going through this graph itself. To do that, all you have to do is click on Inspect, Data, and you have some options on what you would want to look at. You can look at just different trends, or you can look at everything, and then you can download it into Excel. One cool feature that the dashboard has is each of the graphs are synced up. So if you hover over a single point, for example here, you'll be able to see what was happening on all of the other graphs at the same time, making it really easy to extract insight. For example, if we look at this point here where the wind was really picking up, you can see that it coincides with an ever so slight drop in the frequency. Going further in, if your interest is only in offshore wind, for example, you can focus just on the offshore wind curve by clicking on the words offshore wind, and that's all you see. So if we zoom in on the offshore wind curve, you can see when it was windiest and when it wasn't so windy. Looking here, about 3 days ago, it was quite windy, and this ties in with some really important knowledge, because if we look at this curve, we can see there's about 90 megawatts of offshore wind connected at Canterbury North, and that explains why it's the dominant curve. But also we can see when it was and when it wasn't windy. This shows a really good use case of our data. We believe that exposing data like this will allow for better planning of the network, the whole system in fact, and better optimization of distributed energy resources. This is going to be crucial as we head into net zero and the decarbonisation of electricity. Better planning of the entire electricity system will be enabled by sharing this data. But that's only one use case for our data. There are hundreds of possible use cases for this data, and we'd be really interested to hear about what people think our data can be used for and what else they would like to see. We want to co-develop this dashboard with its users to make sure it's as useful as possible. To aid that, we've added a feedback form and an open forum for feedback. If you would like to give us feedback on the dashboard, ways to improve it, different data that could be included, as well as things you really liked, we'd be really interested to hear what you have to say and incorporate your feedback into the future development of this dashboard. We're really excited to hear what you have to say about the dashboard. If you have any questions or feedback, please contact us at opendata@ukpowernetworks.co.uk, or you can contact me directly at harshil.sumaria@ukpowernetworks.co.uk.